Welcome to this video about the chmod command, which stands for change mode. This command is used in Linux to change the file permissions of files and directories. The title of this slide is the chmod command and the subtitle is changing file permissions in Linux. There are two modes in which chmod command can be used. These are symbolic mode and numeric mode. The symbolic mode uses letters and symbols. An example of symbolic mode is chmod user plus execute file.txt. Numeric mode makes use of octal numbers ranging from 0 to 7. An example of numeric mode is chmod 755 file.txt. In this section, let us try to understand file permissions. Each file or directory has three permission sets. First, the permissions meant for the file owner. Second, the permissions for users in the files group, and third, the permissions for all other users. In this slide, you can see a representation of how permissions are structured. The permission structure is divided into three parts: owner, group, and others. Each of these categories has three types of permissions: read, write, and execute, represented as RWX. To view permissions, we can use the command ls-l followed by the file name. An example output is shown in the slide. In this output, the first character indicates the file type, where a hyphen represents a regular file, D represents a directory, and L represents a symbolic link. The next 9 characters represent the permissions. The first 3 characters are W hyphen, represent the owner permissions, indicating read and write access. The next 3 characters are hyphen hyphen, represent the group permissions, indicating read-only access. The last 3 characters are hyphen hyphen, represent the permissions for others, also indicating read-only access. Here, let us discuss the symbolic mode in detail. The symbolic mode syntax is based on 3 components: who, operator, and permission. The who part specifies who the permissions apply to. The U stands for the user or owner, G stands for the group, O stands for others, and A stands for all. The operator specifies whether to add, remove, or set the permission. A plus adds the permission, a hyphen removes the permission, and an equals sign sets the permission exactly. The permission part specifies the permission type. The R stands for read, W stands for write, and X stands for execute. The general format is chmod, who, operator, permission, and the file name. Some symbolic mode examples are as follows. To add execute permission for the owner, the command is chmod u plus x script.sh. To remove write permission for others, the command is chmod o-w file.txt. To add read permission for the group and remove write permission for others, the command is chmod g plus r, o-w document.pdf. To set read permission for all users, the command is chmod a equals r file.txt. To set multiple permissions at once, the command is chmod u plus rwx, g plus rx, o plus r config.ini. Now let us understand the numeric mode. In the numeric mode, each permission is represented by a number: 4 for read, 2 for write, and 1 for execute. 0 means no permission. These values can be added to combine permissions. For example, read plus write plus execute equals 4 plus 2 plus 1, which equals 7. This slide shows a diagram with permission digits for the owner, group, and others. 7 for the owner, 5 for the group, and 5 for the others. Some examples of the numeric mode are as follows: full permissions for the owner, with read and execute permissions for the group and others, is represented as chmod 755 script.sh. This translates to RWX for the owner, R-X for the group, and R-X for others. Read and write permissions for the owner, and read-only permissions for the group and others, is represented as chmod 644 file.txt. This translates to RW- for the owner, R- for the group, and R- for others. Full permissions for the owner, and no permissions for others, is represented as chmod 700 private.key. This translates to RWX for the owner, and no permissions for both group and others. Read and write permissions for the owner and group, with no access for others, is represented as chmod 660 shared env. This translates to RW- for the owner and group, and no permissions for others. Now let us discuss some common permission patterns. For regular read-only files, which can be read by everyone but modified only by the owner, the symbolic command is chmod u plus rw, go plus r file.txt, and the numeric command is chmod 644 file.txt. For directories that are browsable by everyone, but can be modified only by the owner, the symbolic command is chmod u plus rwx, go plus rx directory /, and the numeric command is chmod 755 directory /. For private files that can only be accessed by the owner, such as secure shell keys and passwords, the symbolic command is chmod u plus rw, go -rwx private.key, and the numeric command is chmod 600 private.key. For executable scripts that can be executed by everyone but modified only by the owner, the symbolic command is chmod u plus rwx, go plus rx script.sh, and the numeric command is chmod 755 script.sh. In this section, let us explore special permissions in Linux. There are 3 special permission bits. The set UID, which is represented by the number 4000. When set on an executable file, the program runs with the permissions of the file owner, rather than the user who launched it. Set GID, which is represented by the number 2000. When set on an executable file, the program runs with the permissions of the files group. When set on a directory, new files created in the directory inherit the directories group. Sticky bit, which is represented by the number 1000. When set on a directory, only the file owner, directory owner, or root can delete or rename files within that directory, even if others have write permissions. These special permissions add an extra digit to the numeric mode. Examples include 4755, 2775, and 1777. Some examples of setting these special permissions are as follows. To set the set UID bit, the command is chmod u plus s executable, or chmod 4755 executable. To set the set GID bit, the command is chmod g plus s shared directory /, or chmod 2775 shared directory /. To set the sticky bit, the command is chmod plus t public directory /, or chmod 1777 public directory /. The /temp directory is a common example, where we can list the directory using the command ls-ld/temp. Now let's explore recursive chmod operations. The -r option applies permissions recursively to all files and directories within a directory structure. An example directory structure is shown on this slide. Be cautious when using recursive chmod, as it can be dangerous if used incorrectly. Always double-check your command before executing it. Some recursive examples are as follows. To give read permission to all files in a directory, the command is chmod -r plus r project /. To set full permissions for the owner and read and execute permissions for others, the command is chmod -ru plus rwx, go plus r X project /. To apply different permissions for files versus directories, first use the find command to find all files in the project directory, and then execute the chmod 644 command. Then, use the find command again to find all directories in the project directory, and execute the chmod 755 command. For common web server permissions, the command is chmod -ru plus rw X, g plus r X, O plus r X /var /www /html/. Note that the capital X in symbolic mode only applies execute permission to directories or files that already have execute permission for some user. In this section, we will see advanced techniques with chmod. You can reference permissions, which means you can copy permissions from one file to another using the double -reference option. You can conditionally execute permissions, meaning that you can use the capital X to only apply execute permission to directories or files that already have execute permission. You can also set default permissions by using the umask command to set default permissions for newly created files and directories. Finally, You can combine the find command with the exec option to apply different permissions based on file types or other criteria. Some advanced examples are shown on this slide. To copy permissions from one file to another, use the command chmod --reference equals reference file target file. To apply execute only to directories, use the command chmod -ra plus or capital X, U plus W project /. To find and change mode of only PHP files, use the command find it -type f -name *** php -exec chmod 644 brace close \\. To set default permissions with the mask, use the command -mask022, which gives new files permissions of 644 and new directories permissions of 755. Alternatively, use the command -mask027, which gives new files permissions of 640 and new directories permissions of 750. Now let us discuss common change mode mistakes to avoid. Running recursive chmod on system directories like // etc., /bin, or / can break your system by changing critical file permissions. The solution is to always double-check paths before using chmod -r and avoid system directories. Using chmod 777, which means read, write, and execute permissions for everyone, gives everyone full access to files and directories, creating serious security vulnerabilities. The solution is to use more restrictive permissions like 755 for directories and 644 for files. Removing execute permissions from directories prevents users from accessing files within them, even if the files have appropriate permissions. The solution is to always keep execute permission on directories that you want to be accessible. Applying the same permissions to both files and directories can cause issues, as they typically need different permission sets. The solution is to use find with -type f and -type d to apply different permissions. Finally, let us summarize the best practices. First, follow the principle of least privilege, granting only the permissions necessary for the task. Second, use different permissions for files 644 and directories 755 when applying recursively. Third, double-check recursive chmod commands before executing, especially on important directories. Fourth, use groups effectively to manage permissions for multiple users. Fifth, avoid 777 permissions as they are almost never necessary and create security risks. This slide also contains a quick reference cheat sheet. For regular files, use chmod 644file.txt. For directories, use chmod 755 directory /. For scripts, use chmod 755 script as. For private keys, use chmod 600 private.key. To add execute permissions, use chmod +x script as. For recursive operations, use chmod -ru plus rw, go plus or directory /. In summary, the chmod command is a powerful tool for managing file permissions in Linux, and understanding how to use it properly is essential for system security and proper functionality. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.